Hi, welcome to this lesson on calculus. What is a limit? Let's have a look at the concept of a limit. So, for example, let us consider the hyperbolic function f of x equals 1 over x. So if we sketch this function on the Cartesian plane, we can see something that we called asymptotes of x equals 0, which is the y-axis, and y equals 0, which is the x-axis. But how did we know that these were the asymptotes? So this is where the concept of what we call a mathematical limit helps us give a clear and concise definition of how to classify concepts such as an asymptote of a function. Right, limits also can be used to determine the long-term behavior of a function, which is very useful for us. For example, if you model the growth rates of certain bacteria or viruses, we want to know what's going to happen to that growth rate over the long term. That's where the limit comes in. The limit as the time goes on forever. What will eventually happen? So if we look at this function here on the Cartesian plane, so this is the function f of x equals 1 over x, then we have a special notation to denote the limit of a function. So we write it as the limit as x approaches a of f of x is equal to L, right? Where the function value f at a, so if this x value here is a, and we evaluate the point at a, so this would have coordinates a, comma, f of a, then that value f of a doesn't necessarily need to be the limit value, capital L. So that's the power of limits. So let's see what it means to use a limit. Well, in the case of the hyperbolic function, if we have x equals 2, then we can say that as x approaches the value of 2 from the left and the right, then the function value approaches L equals a half. So what do we mean by that? Well, if for example this value of a here was 2, then on the graph f of 2 is 1 over 2, which is a half. So if you come from the left of 2, so all the values less than 2, like 1 or half or whatever, and they come closer to 2 from the left, moving towards a equals 2, then the y values are also moving closer to that limit value of a half. Similarly, if you come from the right, so a values like 3 or 4 or 5 or whatever, and you start going towards 2 from the right now, can you see your y values also are tending towards that limit point of a half. So the limit here we say exists, and we write it as the limit as x approaches 2 of the function 1 over x is equal to a half. And it so happens that the value of the function at 2 is also a half. So this agrees with the function value at 2. So this concept of a limit is more useful when we look at functions at a higher level and we talk about things such as continuity and then differentiability. All right, but for our purposes, the limit when we look at a function is just what value is the graph approaching when you go from the left and the right of that value, and do they agree, do they meet at that same y value there? All right, so mathematically that's how we write it. And if we look at the long-term behavior, so for example, as x goes towards positive infinity, so here's your x-axis. So as you keep going, your x values keep going to positive infinity, what happens? Your y values are getting closer and closer to 0. So mathematically, we write this as the limit as x approaches positive infinity of the function f of x is equal to 0. So this is how we define what an asymptote is. It is the limit as your x approaches an extreme value, in this case, positive infinity. If we looked at negative infinity, for example, the limit as x approached negative infinity of 1 over x, well, can you see, here's your x-axis. So as you keep going towards negative infinity, can you see the graph here from below the x-axis still goes towards 0, the y equals 0, the x-axis. So that limit's also equal to 0. And that again is an asymptote. What if we looked at another limit? Let's say the limit as x approaches 0 from the right. So that's the mathematical way we write it. The plus symbol means from the right of 1 over x. So here's 0. So if I come from the right, can you see all the values here for the graph go up towards positive infinity? So we can say the limit is equal to positive infinity. It doesn't mean that the y value is infinity. So that's what we mean here. It does not necessarily need to equal the exact value, because infinity here is the concept that we can just keep going on and on and on. And limits is the concept that as you approach the zero from the right, you will approach positive infinity. So that's what this symbolic nature here is telling us. And similarly, if we take the limit as x approaches 0 from the left of 1 over x. So values coming from the left of 0. Can you see your y values are now approaching negative infinity? All right, so that is the power of limits. It helps us determine in the long-term behavior, or as we get close to a point, what happens to that function exactly. All right, so now that we've identified the concept of a limit, let's go ahead and practice some problems, and then we will see how limits fit in when we do first principles for derivatives. Awesome. I'll see you in the next one.